Hello everyone. So in this video, we are going to continue where we left in the last video. Based on trigonometric functions, we did few problems. We would have got an idea how we are using trigonometric identities to integrate the trigonometric function. Now in this, we would be looking into 7 more problems in this video with a different approach. Let's have a check. The first one, evaluate. We have integral tan square x dx. And we know very well that we don't have any formula stating like tan square x. Just have a check. We have sine, cos, secant square we have, cosecant square we have, secant x tan x we have, cosecant x cot x we have. But we don't have anything in tan. So here, as of now, okay. So now when we have tan square x, especially tan square x, we don't have anything for that. We need to use the help of a trigonometric identity. So here we have a formula like secant square x minus 1 is going to be equal to tan square x. If you're unable to recall this, it is like we have sine square plus cos square equal to 1. In the same way, we have secant square x minus tan square x is equal to 1. From this formula only, we derive this one. Even in the similar way, we have one more. Cosecant square x minus cot square x is equal to 1. So, then we would be having like cot square is nothing but cosecant square minus 1. So we would have different problem there. At that time we will use it. So these two identities, now slowly you are learning trigonometric identities also side by side because we may not be able to do the problem if we are not aware of trigonometric identity. So this plays a major role and this one plays a major role. So now let's start solving this particular set of problems. Here we have tan square x and we know that in integration we don't have anything. So in that case, I'm going to convert this in such a way that where I can possibly integrate. And we see that we have something called secant square. So in that case, the tan square is going to be replaced by secant square x minus 1 dx. Now, integral secant square x dx minus dx. What is the integration of secant square x? Integration of secant square x is nothing but tan x minus x plus c. We are done with our integration. Isn't it easy? Now let's work out the next question. We have, let me consider I is equal to, the question goes something like this, cot square x dx. Now in this case, now we have cot square. So which is nothing but cot square x is equal to cosecant square x minus 1. So I'm going to replace my cot square in such a way that where I can integrate where possible because I have cosecant square integration. So let me go ahead with that. So now I'm going to replace cot square with cosecant square x minus 1 dx. Now when I integrate, I would be having integral cosecant square x dx minus dx. The integration of cosecant square x, we have minus cot x. And then integration of dx, that means 1, which is x to the power 0, is minus x plus c. That's it. We are done with our integration. Now, the third one. Let's see what the next problem is all about. Now, here we have a different approach. 1 divided by. When we solve a lot of problems, then only you would be getting an idea how to solve these questions. We have sine square x cos square x dx. Okay. What can be done? I don't have anything like 1 by sine square cos square. Like I don't have, okay, even cosecant is like integral secant square, cosecant square together. I don't have any integration. So in that case, I'm gonna use, we know that Sine square x plus cos square x is gonna be equal to 1. So now this 1 in the numerator, I'm gonna replace it by sine square x plus cos square x divided by sine square x cos square x dx. Now what would happen is integral sine square x divided by sine square x cos square x and then dx plus, because we have two terms in the numerator and both the terms has the denominator has sine square and cos square. That's the reason I'm splitting and writing it so that the cancellation would be happening and after that I can integrate it peacefully. Sine square gets cancelled. Here cos square gets cancelled and I'm being left out with 1 by cos square. 1 by cos square is nothing but secant square x dx plus integral 1 by sine square is nothing but cosecant square x dx. Cosecant square x dx. Now we have an integration formula for these two. Integration of secant square x is nothing but tan x and then cosecant square integration is minus cot x plus c. That's it. Now let's move on with the next one. I think you would be getting ideas how to solve. Like when we solve many problems, we will get an idea about each and every problem. Now we have cos 2x divided by sine square x cos square x dx. So see here. Again, I'm in such a way like I have cos 2x in the numerator and divided by sine square cos square. So now I need to make my numerator in two terms so that one of them would be getting cancelled and I would be able to get it in the format of secant square or cosecant square. Let's give a try. Now I is equal to. Now you guys like which I would have used in the previous video if you would have observed. Cos 2x is nothing but cos square x minus sine square x. I'm going to use this identity. And that means I'm going to replace my numerator with cos square x minus sine square x divided by sine square x cos square x dx. Now in this case, if you observe, I'm having two terms in my numerator. Both the terms has the denominator as sine square x cos square x dx minus integral sine square x divided by sine square x cos square x dx. Sine square gets cancelled, cos square gets cancelled. And then I have 1 by sine square. 1 by sine square is nothing but cosecant square x. Mm, Cosecant square x dx minus 1 by cos is nothing but secant square x dx. And we know the integration formula of cosecant square, which is nothing but minus cot x and then minus tan x because the negative is outside plus c is gonna be my answer. Sorry, c is gonna be my answer. Okay. Now let's solve two more problems of a different approach. Let's have a check. First one, we have 2 plus 3 cos x and then divided by sine square x dx. Like I don't think we need any kind of trigonometric identity with like whatever we have used previously. A simple approach is sufficient, like splitting, because the numerator is already has having two terms. Let me just split my denominator for both the terms and let me write it. It's 2 divided by sine square x dx plus integral 3 cos x sine square x dx. Now, here I would be using trigonometric identity. You guys know one is 1 by sine square x is nothing but cosecant square x. So here I would be having 2 integral cosecant square x dx plus 3 is a constant. Okay, let's come back here. Cos x divided by sin x into sin x. So here cos x by sin x is gonna be cot x. And then 1 by sin x is gonna be my cosecant x. So we have an integration formula for that also. So it's gonna be cosecant x cot x dx. Now let's have a check here with the integration formula. See here. We have integral cosecant x cot x, which is minus cosecant x plus c. And we have for cosecant square x, which is minus cot x, which we have already used. So the new one which we are using right now is minus cosecant x cot x integration. So this is going to be 2 times cosecant square is going to be minus cot x. So minus cot x plus 3 times this is going to be minus cosecant x. Okay, plus c. So I would be having minus 2 cot x and then minus 3 cosecant x plus c. That's going to be my answer. Now let's work out the next problem. We have integral 2 tan x minus 3 cot x the whole square dx. So now let me just say the identity which should come to your mind when you observe the pattern. See, it's a study of pattern everything. So whatever I am able to remember is based on the pattern. When I observe something, it's of some pattern, then I apply it with that formula. So here a minus b the whole square is equal to a square minus 2ab plus b square. And a is equal to 2 tan x and b is equal to 3 cot x. So now let's expand it. I would be having 4 tan square x minus 2 and then 3 you have 6, so minus 12 tan x cot x, that is 2ab. So a is 2 tan x, b is 3 cot x. So 3 2s are 6. Already 2 would be there as per the formula, which is going to be 12. So tan x cot x. Now the next one, plus 9 cot square x and then dx. Now, do we have an integration for tan square x? Do we have an integration for cot square x? We don't have for both of them. So in that case, we would be using something we did in the earlier problem today, first problem. So now here, like tan square was replaced by secant square minus 1 and cot square is replaced by cosecant square x minus 1. Same thing I would be doing here as well. So here, integral 4, I would be taking it out. Tan square, I'm going to replace it as secant square x minus 1 dx. Okay, minus 12, let me take it out. You have tan x cot x. Okay, let me explain something. Tan x is nothing but sin x by cot x. Sorry, cos x. And cot x is nothing but cos x divided by sin x. Now, what happens when these two are getting multiplied? Both of them would be getting cancelled and it is equal to 1. So you have minus 12 dx here. And then plus 9, we have cot square x. Cot square x is nothing but cosecant square x minus 1. So here you write it as cosecant square x minus 1 dx. dx. Now we have integration for secant square, we have integration for cosecant square, and so without any trouble, we would be able to proceed. Now here 4 integral secant square x dx minus 4 integral dx minus 12 integral dx and then minus 9 integral dx and then plus 9 integral cosecant square x dx. So now here 4 times secant square dx is nothing but tan x and then minus 4x minus 12x minus 9x. When we sum it up, it becomes 25. We will take care of that later. And then plus 9, we have cosecant square x. So cosecant square x integration is minus cot x. So what would happen? This plus would be getting replaced with minus. So minus cot x plus c. So here I would be getting 4 times tan x minus 9 cot x and then minus 25x plus c. That's it. Okay. One last question under this type. We have more trigonometry. We would be doing it in the next video. Like one more video or two more videos, it would be based on type 3. Because trigonometry needs a lot of practice, so that's the reason. And then we have like this question goes something like this. Cos 2x minus cos 2 alpha divided by we have cos x minus cos alpha. Obviously, cos alpha is something constant. I'm not going to worry about that. But still, I would be using my identities of trigonometry to solve this problem. So here I is equal to. So now let's observe what I'm going to do. Cos 2x, as usual, we have a formula 2 cos square x minus 1. So it's going to be 2 times cos square x minus 1 minus of cos 2 alpha. Also, I'm writing it as 2 times cos square alpha minus 1 divided by cos x minus cos alpha dx. Now, after this, when you observe, just subtract the minus sign, you multiply inside. You would be getting 2 cos square x minus 1 minus 2 cos square alpha plus 1 divided by cos x minus cos alpha. So if you observe, this minus 1 and plus 1 gets cancelled and you've been left out with 2 times cos square x minus 2 times cos square alpha divided by cos x minus cos alpha dx. Now 2 is a common. So if I take 2 out, I would be having cos square x minus cos square alpha divided by cos x minus cos alpha dx. Now if you observe the numerator, it is in the pattern of a square minus b square, which is equal to a plus b into a minus b. So now let me split that. I would be getting 2 times cos x plus cos alpha into cos x minus cos alpha divided by cos x minus cos alpha. Gets cancelled, you have dx. 2 times integral cos x, we have an integration formula. And then plus 2 times cos alpha is a constant, so I'm not going to, we can't integrate. It's a constant, so I'm taking it out. Okay, and then here when we integrate cos, we get it as sin x. So it's going to be 2 sin x plus 2 cos alpha x plus c. So this is going to be our answer for this one. With this problem, I wind up with this particular part 2. videos of integration of trigonometric functions. Two more videos based on the same integration of trigonometric functions would be there. Thank you.